Hello everyone and welcome to our presentation on thermodynamics and cyclic devices, refrigerators in real-life application. In this presentation, we'll take you through on how the principle of thermodynamics play a crucial role in one of the most essential household appliances, which is the refrigerator. This is our team member, me, Allysa, Binti, and D as the product design engineer, Daniel Ezairy Folorines as the quality control engineer, and last but not least, Gatenie Bulan Judge as cell application engineer. Now I will hand it over to Daniel to begin with an introduction to our company.
Okay, thank you, Allysa. Next, I will explain our company background. So, our company name is a Frostline Appliances Inc. Our company is a leading provider of premium household refrigerators designed to combine advanced cooling technology with modern aesthetics. Headquartered in Kota Kinabalu, Sabah, the company is committed to offering energy-efficient, durable, and stylish refrigerators tailored to meet the diverse needs of households worldwide. So, our goal is committed to eco-friendly practices and energy-efficient appliances dedicated to integrating cutting-edge technology into every products and ensuring durable, reliable, and high-performing products.
Now, let's take a look at the purpose of refrigerator. Refrigerator is a cooling appliance with thermally insulated compartment that remove heat from inside and release it outside. It keeps food cold and fresh by using refrigerant that circulates and change from liquid into gas in that vapor compression refrigerant cycle.
Next, I will explain about the basic principle of thermodynamic of flow processes. So, technically, thermodynamic of flow processes, or well known as mass and energy analysis of open systems, is a study of energy changes in a system where matter flows in, fluids, and out. So, the refrigerator is a cyclic device that removes heat from the refrigerated space. Each main part of the components of refrigerator are related to this study and have the different functions. So, there's four main components, which is compressor, condenser, expansion valve, and evaporator. So the first one is compressor, which is it compresses the vapor to very high pressure, and the compressor needs work energy from electric sources to compress the vapor. And then the second one is the condenser. So the condenser is technically will remove heat energy from the vapor and then causing the vapor to condensate to become liquid. And there's no electric or mechanical energy used in this component. And then the third one is expansion valve, which is the component reduces the pressure of the liquid while maintaining the temperature of the liquid. So the temperature doesn't change and also the enthalpy at the same time. And then the last one is evaporator, which is the evaporator will absorb heat from the refrigerated space. The heat then causes the liquid to evaporate to become vapor.
Now I am going to explain the second law of thermodynamics. The second law states that in any natural thermodynamic process, the total entropy of an isolated system will never decrease. It will either increases or remain constant. This means energy naturally disperses, increasing the overall disorder or entropy of a system. However, refrigerators work by reversing this natural flow of heat. Instead of allowing heat to move from cold interior to the warmer surrounding, refrigerator actively pump heat out of the cold space and release it into the warmer room. This process is achieved by applying external work. Here we refer to the closest statement of the second law, which says, no process is possible whose sole result is the transfer of heat from a cooler to a hotter body. In simple terms, to move heat from a cold area to a warmer one, energy must be supplied. This is exactly how refrigerators work, by applying work through a compressor to drive heat in the opposite direction. Now let's talk about entropy in refrigeration. Entropy is a measure of energy dispersal or disorder in a system. In a refrigerator, entropy changes occur both inside and outside the fridge. Inside the fridge, the refrigerant absorbs heat from the stored item. This process occurs during the evaporation phase where the refrigerant expands and absorbs heat isothermally. As heat is removed, the entropy inside the fridge decreases, making the contents cooler. On the exterior side, the compressor increases the refrigerant pressure and temperature. As the refrigerant releases heat into the surrounding environment during the condensation phase, entropy increases in the surrounding as heat disperses into the air. This process illustrates how entropy changes are carefully managed in refrigeration system, transferring heat from a lower temperature inside the fridge to a higher temperature outside in accordance with the second law of thermodynamics. To make this concept clearer, let's take a look at the diagram here, which shows the refrigerant cycle in action. We can see that the compressor works by doing external work to compress the refrigerant, causing heat to be transferred from the inside of the refrigerator to the outside, making the interior of the fridge colder.
Now I will explain the operation principle of the refrigerator. Starting from the compressor, the refrigerant will enter the compressor at low pressure, low temperature, and in vapor state. The compressor will compress the refrigerant well, and when it comes out from the compressor, the refrigerant is at high pressure, high temperature, and in vapor state. Then the refrigerant will go to condenser coil. Condenser coil is a heat exchanger in the refrigerant cycle. It will cool the refrigerants that coming from the compressor at high temperature. As the heat from the refrigerant is released, the refrigerant will change from vapor state into liquid state. Now it comes out from the condenser at high pressure, low temperature, and in liquid state. Next, the refrigerant goes to the expansion valve. Thermal expansion valve is mostly used in many places. The job is to reduce the pressure of the refrigerants that come from the condenser at high pressure. The refrigerants that comes out from the expansion valve is at low pressure, low temperature, and in liquid state, then goes inside the evaporator. Evaporator is another heat exchanger in the refrigerant cycles. The fan in it blows the air through the evaporator fins. When blown, the heat in the air is absorbed by the refrigerant. As the refrigerant absorbs the heat from the air, we get well-cooled air, and the refrigerant change from liquid state to vapor state. Then the refrigerants enter the compressor bag, and the process starts again. This is how refrigerant cycle work.
Okay, thank you, Bulan. Now I will explain about the refrigerator coefficient of performance. So let's look to the diagram, which is the high heat energy is produced from the addition of low heat energy from cold refrigerated space and work energy input. And then we can see the formula, which is the QH equals to QL plus W in. But however, we want desired output at low heat energy, as we need to maintain the cold refrigerated space at the low temperature. So the formula to find the refrigerator COP is equal to QL over work in. So which is we can get the final formula, which is 1 over QH over QL minus 1.
In summary, household refrigerator apply thermodynamics through the vapor compression refrigerant cycle. They use external work to remove heat from a cold space and release it to a warmer one. With the ongoing technological advancement, companies continue to innovate refrigeration system to make it more efficient and sustainable.
That brings us to the end of our presentation. Thank you for listening.